All right, let's jump right in. Today, we're going to dissect the absolutely explosive evolution of AI and tackle a really critical paradox. If AI is becoming so godlike, why hasn't it completely remade our world overnight? We'll look at this through the eyes of Anthropic CEO Dario Amodei and unpack the two different exponential curves that he says are defining our future.
Okay, so let's kick things off with a prediction that is, and I'm not exaggerating, completely staggering. It basically reframes the entire timeline of AI development, yanking it out of some distant sci-fi future and putting it right on our doorstep.
And the prediction is this: we are just 1 to 2 years away from a monumental breakthrough in what AI can do. Yeah, not a decade, not 5 years, 1 to 2. Which, of course, begs the question, 1 to 2 years until what exactly? What does this breakthrough actually look like? What's at the peak of this insane capability curve we're on? He's talking about creating what he calls a country of geniuses in a data center. Just think about that phrase, an AI that can handle really complex, verifiable tasks from beginning to end. He's so sure about this for things like coding that he puts his confidence at 90% on a 10-year timeline. I mean, in the world of predicting the future, that's about as certain as anyone can be about anything. So to really wrap our heads around how we get to something that powerful, we need a totally new mental model for how these systems actually learn. Because it's not like how you and I learn a new language or a new skill, it's something else entirely, operating on a completely different scale.
And this slide just lays it out perfectly. There are these two distinct phases of learning. First, you have pre-training. And the best analogy for this isn't a person studying, it's more like evolution. It's this incredibly slow, super expensive foundational process that builds the basic brain from scratch using trillions of pieces of data. Then, on the other hand, you have in-context learning. Now that's much more like an individual human learning a new skill. It's fast, it's adaptive, and it happens on the fly.
So here's the crucial point. These AI learning phases don't map neatly onto our own experience. They kind of occupy this fascinating middle ground. Pre-training falls somewhere between our own biological evolution and the years it takes a human to build deep expertise. Meanwhile, in-context learning sits right between that long-term expertise and our ability to just adapt to something in the moment. So what's the engine that's driving this powerful, evolution-like learning process? Well, it all comes down to a predictable principle that we call scaling laws, and one absolutely critical ingredient: the breadth of the data. This is all grounded in what Amodei calls the big blob of compute hypothesis. And the core idea is actually pretty straightforward. It says that progress isn't really driven by 1,000 tiny, clever algorithms. No, instead it's driven by scaling up just a few key ingredients: raw computing power and, most importantly, that vast, broad distribution of data we were just talking about. And here's the big news. We've known for a while that scaling up pre-training leads to these really predictable log-linear improvements. But what's new is that we're now seeing those exact same scaling laws apply to reinforcement learning. You know, the phase where we fine-tune the model on specific skills like math contests or writing code. The progress here is just as predictable. This slide just perfectly captures why broad data is the secret ingredient. You know, early models were trained on very narrow datasets, like fan fiction, and they couldn't really do much else. But then, a model like GPT-2 gets trained on a massive scrape of the entire internet, and suddenly it gains this amazing ability to perform tasks it was never explicitly trained on. Generalization isn't taught, it emerges from breadth. Okay, so this brings us to a major paradox. If the underlying tech is improving at this absolutely breakneck exponential pace, why doesn't it feel like we're living in a completely transformed world already? What's the disconnect? I mean, it's a completely fair question. If an AI that can write its own software is right around the corner, why aren't we just swimming in a renaissance of new programs and tools? Well, the answer has less to do with the AI itself and a whole lot more to do with the friction of the real world. And this brings us to the concept of economic diffusion. This is the critical second curve we need to understand. Think of it like this. There's a gap between inventing the light bulb and actually getting a light bulb into every single home on the planet. Economic diffusion is that process. It's how a new technology actually spreads and gets adopted by society and the economy. Even for a product as powerful as an AI coding assistant, a big company can't just flip a switch and turn it on. As this slide shows, there's a whole gauntlet it has to run. Legal reviews, security checks, training thousands of employees, rewriting old internal software, the list goes on. This process is still happening incredibly fast for a new technology, but it isn't instant.
So our future isn't being shaped by just one exponential curve. It's being shaped by the dynamic interplay between two of them. You have the raw power of the technology, and then you have our ability as a society to actually absorb it.
And this chart just visualizes that gap perfectly. On one side, you have the blistering, almost vertical curve of AI model capability. And on the other, you have the economic diffusion curve. Now, it's still exponential, still faster than any technology we've seen before. But it is fundamentally slower because it's limited by human systems. This table gives us a fantastic breakdown of what's holding each curve back. Model capability? That's a technical problem. It's constrained by compute and data. But economic diffusion? That's a human problem. It's constrained by organizations, regulations, and just our own processes. The example is perfect. It's the difference between an AI discovering a cure in a simulation versus the global effort needed to manufacture and distribute that cure to billions of people. So this is really the key takeaway. The future of AI's impact isn't going to be an instantaneous flip of a switch, but it's not going to be a slow crawl either. We're going to be living in this middle world, a reality that's changing faster than any other time in history, but with real tangible delays caused by the friction of actually getting things done. And this leaves us with a final and pretty provocative question. The great strategic challenge of our time is going to be navigating this two-speed world. How do you plan for a future where technical genius arrives in 2 years, but its full economic impact might take 5 or even more? Thank you for joining this explainer.